these different filters, because there's so much that just is hiding, particularly in totality. There's lots of different things that can happen there as well. And I wanted to share with you a really fascinating image that we received from NASA here that is absolutely fantastic. It's it looks like there's a hole in the world, to put it lightly. But this is something where we have a view of an eclipse. This was taken in 2006 of
Eric,
as it's viewed by the International
on our
Space
video
Station.
feed. We do have the eclipse starting.
Oh,
We've
the
got
eclipse is
first
starting.
contact.
Oh, very exciting. I will change to that ASAP. This is a very hectic day, ladies and gentlemen, because we're fighting with the clouds and we're trying our best to get you what is coming on. And so, yes, I'm seeing the sun just popping out of the feed there. We will get that for you momentarily. And so it really must be an amazing sort of tug of war for you today, Paul, in terms of trying to get when the clouds are going to come out, or when the sun is going to come out of the clouds. Is there just a lot of refocusing and stuff that you have to do all the time?
Yeah, absolutely. We're having to kind of repoint the telescopes every time this comes through. So on this particular feed that we're watching now live, just on the right-hand side, you can see that tiny little chunk of the sun being taken away by the moon. And yeah, you're right. Because the sun is obscured behind the clouds every now and again, we're having to refocus, repoint the telescopes. That means removing the filter very quickly to find the sun again, putting it back on again. So, but this is fantastic, Eric. We have captured, albeit through the clouds, we've got first contact of this eclipse. So it's promising. The sun is teasing us from behind the clouds. But frankly, you know, it makes it all the more exciting. Now, viewers will have, as Eric said, viewers will have to bear with us, because we will suddenly have to divert from our conversation or tweak a system or tweak an image here or there. So, but stick with us, because we're doing that to bring you the very best coverage of this total solar eclipse.
I couldn't have said it better myself, really. And thank you so much for all of you that are tuning in to witness this battle. I want to welcome you to tweet us any questions that you might have to the hashtag Slooh Eclipse, because we are happy to answer those throughout the broadcast, live on the air. If there's stuff that you're curious about that is happening, oh, it's just so cool to see that slice. If there's stuff that you're curious about, we would be happy to answer them, and we're going to be following that hashtag throughout the broadcast. But we do have to take a short commercial break. But before I do, I want to encourage you to consider perhaps joining Slooh. You can see content like this, and you get to try us for 30 days for just $1. So look into us at slooh.com and see if you're interested. But yeah, we will be right back. We're going to talk a little bit about what makes an eclipse so special, so unique, particularly when you're viewing it from Earth. There's a very, very magic number, that number being 400. We're going to get into that a little bit right after these quick messages. Stay back. We have our feed now live from the Faroe Islands. It's really, really exciting to see this sun poking through these clouds. I'm going to get our faces off of there, actually, because we might be in the middle of where the slice that's coming off of the sun is. Isn't it right on that right side there, Paul? Oh, this is absolutely, it's absolutely a gorgeous eclipse. Really, we're looking forward to just seeing what is going to happen with all these clouds. It's such a dynamic experience. And one thing that I wanted to talk to you guys about a little bit was what does 400 mean? Why is 400 so exciting in terms of these eclipses? And that is because the sun and the moon and the Earth are in a very unique position when it comes to their orbits. And so the moon is actually about 400 times as small as the sun, but it's also about 400 times closer to Earth. And so what happens there is that we get a total solar eclipse where we see that these objects actually seem so similar to each other in size in the night sky, but well, they're actually so vastly different. And so because we have that really magical proportion, that it's this very special event that we can see because of this number 400. And
it's a cosmic coincidence, isn't it, Eric? You know, that we just happen to be, because the moon hasn't always been that distance from Earth over millennia, over millions of years, and it's actually going further and further away from us. So I don't know how long, but in a few million years, you won't get solar eclipses anymore because those magic proportions, that 400, is gone. So we are very fortunate.
Absolutely. Yeah, I actually just calculated that earlier on today. So the moon is actually moving away from us at a speed of about an inch or about 3 centimeters a year. It's really a Speedy Gonzales over there. And what it needs to get about 17,000, I believe, kilometers away for us to no longer experience a total solar eclipse. And so for that to happen, for us to be moving away at an inch a year, it'll take us about 500 million years. So to my guess, we'll probably have a few more total solar eclipses before then. You don't need to worry. Maybe like 2.5 or 3. Possibly. So we'll have a couple before that happens. We just have to figure out how to gain immortality to see those 500,000, those eclipses way in the future. So that's something we can work towards. But one of the things that is interesting about all of this is really that you can see a very incredible example of how this is not true for a eclipse that is happening on another planet. Like, for example, if you go to Mars and Mars's moon Phobos, like what do you think would be the situation over there? Do you think Phobos would completely overshadow the sun? It would be way too big, or would it be way too small? What are your thoughts on that?
I would have to be a guess, Eric. What do you reckon, Phobos? Yeah, actually, it's quite big in comparison to Mars, but not as big. It's further away. I think it's going to give a total eclipse. Would you get a total? Oh no! Look at that. Okay.
Yeah, it actually gives you a really significant annulus right there. It's really smaller than the moon, and it's not close enough to Mars to be able to match that. The magic proportion isn't there. That's what we need. And so this is an image that was taken by the Curiosity rover in 2013 of an eclipse of the moon over there. So that's one adventure. And there's also the possibility of Jupiter. Jupiter has a lot of different moons. And so what do you think? Would they be what about Io? Io is really one of the the standard moons of Jupiter. Do you think that'd be bigger or smaller? Well, what are your thoughts?
Oh, that's going to be tiny. That's going to look more like a transit of Venus across the sun from Jupiter. So nowhere near total. It's just going to be a small spot transiting, and frankly, the sun's going to look incredibly small from Jupiter. That's a long way away.
I mean, yeah. I mean, you would think it would look so tiny, but the fact is this: it's because the sun is so far away. The difference between Io and the sun, it's just so enormous. Like, Io would completely be so much larger. And so, this is a tale of Goldilocks told in space, told in the cosmos. And so it's where in Mars it's too small, Jupiter's too big. Earth is just right. Earth is the bed that Goldilocks would sleep in, so to speak. And it's so fun to see, and it brings home how unique Earth is for having this incredible opportunity to see these total solar eclipses. What we're trying to bring to you today. Oh, and it looks like we have an incredible image coming in from our feed in Austria. Let me pop up with that in just a moment. Let's see. But as I do, so what are you most looking forward to in terms of seeing this eclipse, Paul? Is there something that's really exciting you? I mean, I know, of course, there's totality, but maybe a portion of totality that will be really interesting, something that we can tempt our viewers with.
Yeah, well, there's a number of different phenomena that we experience during an eclipse. And the first of those is what's called the diamond ring. Now, that's a really kind of famous, iconic image. Oh, talk about this image. This is a live image, is it? Yes.
Yeah, this is a live image coming in from Austria right now.
Fabulous.
So gorgeous.
That's in H alpha. So this is an H alpha view. This is, it's stripping away all the visual white. I've got some feedback there, Eric. This is filtering out the visual light. So we're just seeing the H alpha light, which means that we can see all of these beautiful features on the sun's surface. And we're going to be talking to Matt Francis later, who's a solar expert, has his Prescott Observatory, Solar Observatory in Arizona. And he's going to tell us all about these different features, but it's absolutely fabulous. We are going to talk also later on about the 2 coronal black holes that have been spotted on the sun last week. These are enormous dark patches on the sun, which actually caused the geomagnetic storm that we experienced a few days ago, which is why everybody was able to view the aurora, or people who wouldn't normally see the aurora were able to. Anyway, let's go back to some of the phenomena that we can look forward to. The first one, as I say, is the diamond ring, and that is, it's stunning, but it only lasts for maybe 10 seconds or so. And it's just before the moon totally covers the sun. But then we get another exciting thing to see. We start to see Bailey's beads. And these are, the surface of the moon, as we know, is cratered and it's rough, and there are mountain ranges and valley. And it's where the sun just pops out through all of those valleys, through all of the valleys. Sorry, I was being a little bit distracted there. Sorry, Eric.
Oh, no problem at all. But I think we just got a great Twitter question that I think would be great to discuss here, that I'm just bringing up, from Theo, where he's asking, why does looking at the sun in an eclipse harm our eyes? Do harming electromagnetic waves refract? Are they refracted or something? And so that's a good question, and I think it's a really important thing to discuss at every sort of total solar eclipse or any sort of eclipse, in that we need to understand, that it's really important that we don't look directly at it. Can you give us, or maybe our viewers, some safety tips there, Paul?
Yeah, absolutely. I mean, an eclipse is no different to normal everyday life when the sun's out. You don't even look at it directly, even with sunglasses on. If you're going to watch the eclipse today, you have to have a pair of eclipse glasses, or you have to use another method that we're going to explain to you. Yeah, eclipse glasses are the things to have. If not, you can get 2 pieces of card or paper, make a hole in one of them, hold that up to the sun, and project the sun through onto the rear piece of paper. And you have to move it backwards and forwards to get it into focus. But what you'll see is this perfect image of the sun with a little crescent cut out of it where the moon is. But you can also do this with just normal household items. Go into your kitchen, get a colander, and anything with a hole on it, hold it up to the sun, and it will project the shadows that project down onto the ground, or a piece of card or anything like that will show the eclipsing sun with this huge chunk taken out of it. So that's a really safe way of doing it. If you haven't got any of those things handy, let's say you're out in the countryside and you're close to some trees. The shadows cast by the tree onto the ground during an eclipse will also cast these little crescent suns, which is absolutely fabulous. So there's a whole number of ways to look at the eclipse visually, but you don't do it in any way without eye protection. Now, there's one slight omission from that, and that is at totality. So if you're in the Faroe Islands like we are, if you're in Svalbard, which is the only other location in the world who can see totality for this eclipse, you can look at totality directly with your eyes. And that's when we start to see the other fantastic thing that we see during an eclipse, which is the corona, which is the outer atmosphere of the sun, and it's sculpted by the magnetic fields of the sun, and it can change in size depending on solar activity. So we are hoping today that following the recent geomagnetic storms and solar activity, that we're going to see some beautifully sculpted coronas, and maybe we'll see the effect of these two coronal holes that we're also going to be looking at and discussing later on in the show. But just to give you a bit of a roundup, you're watching Slooh.com. I'm Paul Cox. Our producer, Eric, is in the United States. I'm in the Faroe Islands, and we are here to show you these wonderful live images of the solar eclipse. We haven't just got images from the Faroe Islands, but we've got them from elsewhere. What are we looking at here, Eric?
We're looking at a live view from Austria. Well, our faces are in the way, actually, of this incredible bite that's being taken out of the sun right here. It's absolutely gorgeous to look at. We're seeing the sun being bitten to pieces by the moon as it's coming closer and closer to encroaching upon the sun in its maximum state. It's really it's a gorgeous thing to see, and I was really I was excited listening to all of the different features that you were mentioning, Paul, in terms of just what we're going to see. It's so rare that we have something so dynamic in our sky, something that will change in a way that's easily visible, so fundamentally to the human eye. And it's
there's something
really
that we can, sorry, Eric, there's something that we can see now on this H alpha image that otherwise, without this kind of filtered image, we could only see it during totality, and that's called a prominence, right? And just to the left of the sun, you can see a little white kind of jet coming off, and that's a prominence. So that's going to be really cool, because at totality, we're going to be able to see that visually with our eyes.
It's going to be it's already getting absolutely incredible, and we have somebody who's going to be talking about prominences with us very soon. I don't know about you, Paul, but I'm very excited to hear what Matt Francis has to say in terms of his experience with the total solar eclipse. It's going to be very exciting to hear about. But before we do that, I was thinking that it's really exciting to hear about why exactly we're having an eclipse in such a unique location. Really, on any place on Earth, the total solar eclipse can only be seen once every about 360 years. It's so rare that we get to see an eclipse in one location. And the United States should be very excited. In a couple of years, August 21st in 2017, we're getting a total solar eclipse going right through the United States. And so the people that are viewing this here and are feeling a little bit sad that they're remote can now have an opportunity to interact in that way directly with a total solar eclipse. It's looking very exciting. And also, there's going to be an eclipse coming up a little earlier than that for people in Southeast Asia in 2016 on March 8th and 9th. People should be really looking forward to that. But